Hi. So we'll solve two questions which are very common in exam. It's a very exam oriented question. And the same reactant, as you can see here, the same reactant but with different reagent. One reagent is lithium aluminum hydride in ether, and it is a nucleophilic reagent. It supplies hydride H minus, and this is DIBAL-H, that is diisobutyl aluminum hydride. So I'll make a separate video on this reagent later. And it is used at minus 78 degrees centigrade. It can also be used at room temperature. In the second example, it is used at room temperature. So the outcome will be different here. So we have to know what will be the outcome, which functional group is reduced to what by which reagent. Okay, so this is lactone. This is lactone. Now when this lactone is treated with lithium aluminum hydride in ether, it does what? It supplies H minus. As I said before, it supplies H minus. Okay, and first it form the structure like this. Okay, it supplies hydride H minus. It supplies H minus, and then this bond breaks. Okay, now it's a aldehyde. This group is aldehyde. Now in presence of lithium aluminum hydride, it will again get reduced. Again this H minus will attack this aldehyde carbonyl center, and it will produce alcohol OH. So diol. So a diol will be produced. Now here, when you use diisobutyl aluminum hydride, in short DIBAL-H, then what will happen? Then it will produce this is known as lactol. Okay, so it will only reduce this carbonyl group. It won't reduce further, and this lactol can open up like this. It's having lone pair, and it can open up like this to this structure, like this one and this one. Okay, so but diisobutyl aluminum hydride DIBAL doesn't reduce this aldehyde group. Okay, why so? I'll discuss later that only at room temperature DIBAL-H reduces this aldehyde group, not at a very low temperature minus 78 degrees centigrade. Okay, that's the reason is the product at minus 78 degrees centigrade. Okay, so we have to take care of the temperature also. Now here, now see second example. This is cinnamaldehyde compound, and it's having, as you can see, this double bond. It's in conjugation or with this phenyl ring, and also it is alpha beta unsaturated aldehyde. See, this is carbonyl group, so this is alpha, this is beta. So alpha beta unsaturated aldehyde. Now when we use lithium aluminum hydride, so lithium aluminum hydride basically reduces this polar multiple bond, but here it is a carbon-carbon bond. It's not polar, but it also reduces this carbon-carbon bond because it's in conjugation with this phenyl ring. Since this double bond is in conjugation, it also reduces this double bond. Okay, so it becomes saturated, and it reduces, as I said before, that it reduces aldehyde group, so it becomes alcohol. Okay, now here, when I use DIBAL-H at room temperature, then what happens? This DIBAL-H doesn't reduce this multiple bond. It only reduces the aldehyde group at room temperature. So here is the difference. The double bond remains intact, and here the double bond is gone. So when this reactant is given and the product is given, you have to identify the reagent. Then be careful, and I'll later upload a detailed video on this separate reagent. Okay, so let me know whether you liked it or not. So that's all the session is all about. Thank you. Bye bye. Take care.